Welcome to our 9th lesson on the quantitative aspects of chemical change. Our focus today will be on concentration. Now, concentration is seen as the amount of dissolved substance, and typically this will be dissolved inside a solvent. Now, let's go and talk about the difference between solvent, solute, and the solution. Now, solute will be the solid particles which you would like to go and dissolve. Solvent would be the liquid in which you would like to dissolve this solid in. Now, once your solid have been dissolved, then we'll call it a solution. Now, your solid, for example, in this case could be salt, sodium chloride, which we dissolve in water and then will form a salt solution. Now, the amount of salt that would be dissolved inside my water in the salt solution will then be seen as the concentration. Now, it's going to have a specific unit, our concentration, and a symbol. Our symbol, which we're going to be making use of to indicate concentration, is a small letter C. Please make sure that it's a small letter and not a capital letter. Our unit for our concentration is going to be, though, moles per cubic decimeters. So that means moles divided by cubic decimeters. Now, you have already learned about moles, and you note that will obviously stand for mole, and our cubic decimeter would then be the unit in which we would measure volume. Let's go and take a look at how our formula would look like, from which we can go and calculate the concentration. So our formula here would be made up of N at the top, which is moles, measured in mole. Remember, there can be an E at the end. It will still mean the same thing. Capital letter V, that stands for volume, measured in cubic decimeters, must be in cubic decimeters, and then concentration measured then in mole per cubic decimeters. So the reason why we have to have volume in cubic decimeters is because of my concentration that needs to have it in cubic decimeters. But let's say that they've given it to you in cubic centimeters. How would we convert that to cubic decimeters? Now, first off, if we had normal centimeters, taking them to decimeters, then we would have just divided by 10. But we've got now in this case cubic centimeters having to go to cubic decimeters. So we're going to need to cube this 10 as well. And that ends up being then 1,000. So going from cubic centimeters to cubic decimeters, we'll have to divide by 1,000. On the other hand, if we want to go from cubic meters to cubic decimeters, now once again, if I just wanted to go from meters to decimeters, I would have ended up by multiplying by 10. But because it's now cubic meters to cubic decimeters, I've got to cube the 10 as well, and therefore it ends up being times 1,000. Now let's go and take a look at your formulas again. If we would like to end up calculating moles, remember that this line at the top means divide by, and the one between the concentration and volume is multiply by. So if I want to calculate moles, it will end up being concentration times the volume. Note though that moles and concentration is small letters, whereas volume is a capital letter. If I want to calculate the concentration, it will be moles divided by volume. And if I want to go and calculate volume, it will then be moles divided by concentration. Now, you have learned from your previous lessons that moles will be equal to mass divided by molar mass. So should you end up having to go and calculate moles as well before you can finish your concentration calculation, we would know that moles is equal to mass divided by molar mass. So let's say you want to go and calculate concentration. And you know from your newfound formula, it is moles divided by volume. But you do not have the moles and would first need to go and calculate it using your formula mass divided by molar mass. Then you can basically substitute mass divided by molar mass back into your concentration formula. And this will then make concentration equal to mass at the top divided by volume and molar mass at the bottom. Now, you don't need to use the formula as this. You can go and use your two separate formulas in your calculation, but do take note that there is a simpler way where you can combine these two formulas into this following one. Now, let's briefly talk about a standard solution. Now, a standard solution is a term that refers to a solution of which the concentration is known and will stay constant for a period of time. So that means you know exactly how much of your solute you've added into the solvent, and you know then what the concentration of the solution will be. So let's go and take a look at an example like that. It asks us first to calculate the concentration of this standard solution that was made up of 3 grams of my salt that was dissolved in 200 cubic decimeters of water. Good, so we want to go and calculate concentration. According to my formula, it will be moles divided by volume. But we do not have the moles and would first need to go and calculate that, making use of mass divided by molar mass. Now, as we said, we can go and combine this into one formula. Let me make use of this to explain how it works again. So I can go and replace the moles with the mass divided by the molar mass, which means I'll end up with mass at the top divided by molar mass times volume at the bottom. Let's go and punch in our values and see what we end up with. So the mass of the sodium chloride was given as 3. The molar mass of sodium chloride that you'll need to go and calculate using your periodic table. Sodium is 23 plus chlorine is 35,5, and then we'll multiply that by the volume, which luckily is given in cubic decimeters, of 200. Now this is going to give me a concentration of 2,56 rounded off to 2 decimal places times 10 to the power of -4, and remember concentration is moles per cubic decimeters. So it's mole divided by cubic decimeters, which can also be written as such. Now the next thing that we're going to take a look at for our concentrations is molarity. Now in molarity you need to remember that cubic centimeters will be the same as a milliliter and cubic decimeter is the same as 1 liter. Now molarity's formula states that it's the moles of the solute, remember that's the solid substance that was dissolved, divided by the liters of solution. Or, seeing that we know that liters is equal to cubic decimeters, it means you just need to make sure that the solution then is in cubic decimeters when you divide with it. Now let's go and apply this to an example. Now the example says go and calculate the molarity of the solution that was made up of 3 grams of sodium chloride that was dissolved in 200 cubic centimeters of water. Now in order to go and calculate the molarity, we said we need to dissolve or make use of the moles of solute divided by the liters of the solution. Now we at this point do not have the moles of the solute. We would need to go and calculate it using mass divided by molar mass. So the mass of sodium chloride was 3 divided by the molar mass, which is then the 23 plus 35,5. Now this ends up giving me a mole value of 0,05 with quite a few decimal places, which you will keep, seeing that this is not my final answer. So this is my amount of moles for the solute. Let's now go and divide it by liters of the solution. And remember, liters means cubic decimeters. So I'll need to take my cubic centimeters to cubic decimeters, and we'll do so by dividing with 1,000. So we'll take our 200 cubic centimeters divided by 1,000, which will end up giving me 0,2 decimeters cube. So thus it will be that 0,05 with all of its decimal places divided by 0,2. And this gives me molarity, rounded off to 2 decimal places, of 0,26. Now we will call this then molar, which is indicated by a capital letter M, and as we said, it doesn't now stand for molarity, it stands for 0,26 molar. Now the question which I would like you to go and attempt to ask you to calculate the concentration of 40 grams of sodium carbonate in 500 cubic centimeters of water. So first pause your player and attempt the question before you're going to be taking a look at the answer.